Okie dokie, 3.1, graphing, quadratic, functions. The good news is this, we know most of this stuff, okay? With this chapter, we are starting to go through and get the little things about each individual function. All right, and that's basically kind of what the rest of the year is about. Okay, we start looking at individual functions throughout each chapter. So the first one we're going to do is quadratics. All right, with that, a quadratic function, it's a function with the greatest exponent being 2. All right, if you look up here, and you'll see in general form is what this is called. It's called the general form of a quadratic function. You've also seen what's called vertex form. We will eventually get to that. Okay, the differences. For now, though, you're mostly going to work with the general form of a quadratic. Yes, sir.
How come there's no x on the c?
That's I'm going to get there. Okay. Now your quadratics work in like this when it's in general form. You have an x squared part, you have a x part, and you have a constant part. That's what these three terms mean. Okay, you have a quadratic term, a linear term, and a constant term. Now, in most cases, all three parts will always be there. Okay, it's just part of what makes the function so. Okay, that's why it's set up the way it is. Sometimes, occasionally, your bx term, your linear term will be missing. Occasionally, your constant will be missing. But your ax squared term will always be there because otherwise, it's not a quadratic. It's a linear. Okay? So basically, instead of having y equals mx plus b, or f of x equals mx plus b, you now have three parts. Ax squared, bx, and c. Okay? Make sure you know the names of these terms. Quadratic, linear, constant. Okay, make sure you know that. Highlight that up. Okay, David.
So anytime it's a function and it has something that's squared,
yes.
Always be a parabola.
The graph of it, well, yes. That's the next part. That's the graph. You have the function itself, which is the equation. That's called a quadratic. The graph, when you go graph it, that shape is called a parabola. That's the difference. Okay? Does that make sense? Fantastic. Moving along. Okay? Now, bless you. Most of this we are going to either already know about or we're going to use our calculator for. Okay? So a lot of this is kind of review a little bit since we did do last lesson, last chapter. Okay? First thing, axis of symmetry. It's very similar to line symmetry. Okay? The line symmetry you found in chapter 2, that's the exact same thing except now they call it an axis of symmetry. Okay? A line through the graph of a parabola that divides the graph into two congruent halves. It's almost the exact definition of line symmetry, except now it's axis of symmetry, okay? Most important thing to know, or word to learn, I guess, is called vertex. Okay, the vertex is the only point the axis of symmetry will intersect a parabola. Okay, so if you look at this down here, obviously you guys know this is a parabola. Okay? The vertex is the lowest point, like down here, or if you flip it, it's the highest point. Alright, it's either the lowest point or the highest point. The parabola, if it was flipped. Okay? That's your vertex. Now, the nice part about this is once you have that vertex, you'll have everything you need to go graph it. Okay? And that's what we're basically going to do today is graph these real quick. Graph them somewhat accurately too. All right, so for this bottom box here, this is important stuff down here. Okay, first off, considering the graph in general form, ax squared, bx, and c. Okay, here's your definitions. The y-intercept, if it's a y-intercept, it's where x is 0, so that means that c is the y-intercept. Okay, not as important, but can be helpful from time to time. All right. The equation of your axis of symmetry. Okay, like last time how we just looked at it and got your line symmetry, right? X equals this, x equals that. And you just looked at the graph, right? Remember that? Today, some of these may not be right on a line. All right, right on a nice line. Some of them won't be. But the way you figure out what that line is right here. Negative b over 2a. Okay? And the a's and b's come up from up here, right? So if you're given a quadratic, you have negative b over 2a. Now that's the equation. Follow along with me here, okay? It's kind of like a proof thinking, all right? If that's the equation of your axis of symmetry, negative b over 2a, and the axis of symmetry is the only place is the only point that the axis, or sorry, the vertex is the only place the axis intersects, that means that negative b over 2a is also the x-coordinate of the vertex. Okay? These problems start right here. Negative b over 2a. I'm going to say that at least 20 times today. Okay, okay. Any questions so far? Let's do. Don't worry yet. This is just the details, or not details, but just definitions. Okay, you'll see one here now. Okay, graph. F of x equals 3x squared minus 12x plus 6.
Reduce.
By making a table. No.
No?
No. Your first thing you want to do is do negative b over 2a. That's first. Okay, which is why it's important to know a, b, and c. Okay. Now those are just the numbers, the coefficients. They're not the variables themselves. Okay, Marks.
Those mixed up to where when you look at the problem,
They can be in a different order, but you need to make sure you write it in descending order from your exponents down. So your a is always going to be with your x squared. Your b is always with your x.
Okay.
Your c is always by itself, no matter where it is in line. Okay. Does that make sense, everybody?
Do you use the negative b divided by 2a all the time?
Yes, that's always your first
So
step.
that's what you just, so it'd be 12 divided by 2.
There you times
What?
12 divided by 2 times what?
A?
A, which is
3x squared.
nope, just 3.
Oh.
Okay. So negative b is negative 12 too. Okay, it goes together. Okay, so minus negative 12 divided by 2 times a, which is 3. Okay, clean it up from there. So you have negative times negative 12, so that becomes just 12. 3 times 2 gives you 6. 12 over 6 gives you 2. Okay, so when you go to start your table right now, you know that the first x you want is 2. Okay, now how can you find that 2's corresponding y? What can you do? What's the relationship between these numbers?
Plug 2 in for x.
There you go. Plug 2 in for x, and that gives you the y that goes with it, right? Remember from functions that we started with when we did that the other day? You plug the number in, you get the number out. That's the relationship between the two. So now you plug 2 into your function. So 3. Let's do this in green up top here. So 3 times 2 squared minus 12 times 2 plus 6. Alrighty.
So you do the square first?
So you do your exponent first, right? Follow PEMDAS. Alright, so 3 times 4. And I kind of like to keep all my operations the same throughout, so I don't multiply ahead of every other multiplication, alright? So you get 12 minus 24 plus 6, which ends up giving you what, negative 6? Perfect. So you have your vertex is at 2, negative 6. So 2, negative 6, way down there. So like I said, I'm going to cheat. Let's see here. 3 and 1. Go with negative 3 and negative 3. And how about 0 and 4? Go with 6 and 6. Okay, just write that down for now. All right, trust in your teacher, and I'll explain how I came up with those in just a second. All right, but I want you guys to get the picture first. Okay. So then go plot those points All right, so we got 3, -3, 1, -3 like that, right? And we got 0, 6, and we got 4, 6 like that. All right, now, as you guys probably figured out already, these are kind of a pain to draw. Just do your best, okay? So, and then all you need to get, like, see, I can't even do it good. All you need to get is 5 points. Thunder. All you need is 5 points. You never need more than 5 points. Okay? Sometimes your graphs will only allow you to get 3. That's okay. If you can get a 4th and a 5th, that'd be great. A little more accuracy to it. But if you can only get 3, that's okay too. You'll never need more than 5. Okay? Does that make sense? Now, this is going to be a little, I'm going to kind of go over this really quick because I think we all know how to do this already. All right? Was anybody looking over when I did this?
I was trying to figure out what
You were going up by. No, you.
How did I figure out these numbers?
you're on your calculator.
I was on my calculator. Okay, let's do
You
that.
go to your table.
I went to my table.
Oh, and then
Did
you
you
press
plug-
second graph.
Exactly.
You plug in a thing.
Exactly. Okay. Now, here's the key, though. Here's the key. You can't just plug this in.
You have to find the first one.
Exactly.
Wait, what?
You can't just, here's my point. You can't just plug this into your calculator. Okay? You can, it shows you the picture. All right, I get that. But you're not going to really draw a great picture from this, are you?
Huh?
Yeah.
Okay? Are you really? I doubt it.
If you
No, you're not. Okay?
you're right.
I know. I've seen people try. It doesn't work. Okay? So then, you need to figure out your vertex because your vertex is your what?
Starting point.
Your center. It's your starting point. Once you get that and you have that, so see how I have 2? Notice my x's. From 2, I went to 3 and 1, which are both how far away from 2? 1 point, right? Okay. 3 and 1 are both 1 away from 2, yes?
Yes,
Okay.
they are.
Now, one more connection. I know there's a lot of moving parts here. If my line or if my parabola is going to be symmetrical, and that 3 and 1 are both 1 unit away from the vertex, don't start packing up yet. You got 5 minutes. Some are. If they're 1 away, those 2 values have to be the same, those 2 y values, otherwise it won't fold on itself. Make sense?
You're right.
I know. It's like I've taught this before.
Okay, so then how did you get this 0 and 4?
I'm just
This-
Because he gets it in the table. Because he plugs in the x and y because he has to find the first 2, so that's where you can start from. You have to find your starting.
Does everybody have the graph down? Everybody have the table down?
I got
Here's the graph on your calculator, right?
yeah.
Okay. Now, if you just draw that graph and you try to eyeball it from there, you're probably going to mess up. Sorry, it's true.
Right, you can't press the table.
Okay. But you go second graph and that pulls up your table, right?
Right.
Okay. Now, here's my point to this. If you just go pick 5 points, 5 random points, okay? So let's just say -2, -1, 0, 1, and 2. Okay? You only get that left side. Okay? Because you don't hit your vertex until you actually get to -2. So if you picked 2, 1, 0, -1, and -2 as your 5 points you're going to use to graph, you would only be on this left-hand side. Okay, get what I'm saying now? So I want you guys, like Dimitri's saying, you find that center point. You do -b over 2a, you get your vertex.
Right.
Okay? Now, sometimes your vertex won't be perfect. I'll tell you that.
Like a fraction.
Right. Okay?
So
David?
sorry.
It's okay.
Yeah.
Not really.
Alright, sorry.
Okay, it's all good. So if you have that not being perfect, that's okay because you know how to find just that vertex. Okay? That's the example we're going to do next. Those of you that are leaving, you'll miss that one, okay? So make sure you watch that. Yeah. Okay?
My question.
So, David, go ahead.
Still be on Schoology, right?
David, go ahead.
Find the vertex. What do you need to do after that?
Once you find the vertex,
Yeah.
you plug it in your calculator. You go second table,
What do you plug in?
the function, the 3x squared
The following number.
minus 12x plus 6. Yeah. Okay, you
Okay.
plug that in. All right. You find your vertex on the table,
Yeah,
which is 2, negative 6. Right?
yeah.
Once you have that, the 4 numbers you saw me pick were the ones that were 1 and 2 up and 1 and 2 down from your x of your vertex. That's the 4 you should pick.
Does it matter what 5 you pick? Yes.
Yes.
You just said that.
Oh, so you choose the 2 because.
Those are chances are those are the ones that are actually going to fit on your graph.
Alright.
Okay? Is the ones that are the closest to it.
But you chose the 2 because you substituted the 2 in the beginning when you tried to solve it.
Because when you did negative b over 2a, 2 is what you got.
Oh, okay.
So you plug that in. That's the
You
x
go by
coordinate
2 on your graph.
to your vertex. Right. Okay, so typo alert. Change that from 4 to 5. Okay, make that x squared plus 5x minus 3. All right, now go about it the exact same way. Negative b over 2a always goes first. All right, so b in this case is 5, so negative 5 over 2 times 1, which gives you negative 5 halves. This might be a case where you might be better off with decimals, all right, just so you don't have to think about what negative 5 halves actually is on a number line, okay? So you do negative 5 divided by 2 real quick, and it's negative 2.5, okay? So this is probably a rare case where I actually prefer decimals. That way you know right where you're at on an XY number line, right? Make sense? Okay, so there's your x. Now plug it in. So x negative 2.5 squared plus 5 times negative 2.5 minus 3. And if the next thing I see is that value, okay, that's perfectly fine with me, guys. I don't need to see all that extra work. Okay, I don't need to see you squaring this and then combining, multiplying, and combining like terms. There's going to be enough work to this that if you go straight to your calculator with this step right here, I am perfectly okay with that. All right, at this point in everybody's lives. All right, so then when you do that, you get negative 9.25. Okay, so that's your vertex, negative 2.5. Negative 9.25, okay? So now, here's the ugly part about one where a vertex isn't nice. You won't have a nice coordinate for it. So just do the best you can. All right, so negative 2.5, you know, it's about right here. Negative 9.5 is actually off of this graph. My fault. I thought this went to 10. So it's probably, you know, let's see, that'd be negative 9. So it's probably right here in the purple. Nope, I'm one too far to the left. Probably right there. Okay. Everybody good at that point? Okay, now I'm not actually going to show this graph as far as like me graphing it. But I am going to show on here, okay? So what you should look for. So x squared plus 5x minus 3. And you hit graph. And that's what the graph looks like. All right? It's going to look something like that. And then you go second graph, and you bring up that table value. All right? Now, what was our vertex x coordinate? Negative 2.5. Okay? So our vertex lies between negative 2 and negative what? Negative 3, right? Negative 2.5 is between negative 2 and negative 3, right? So that's where you go onto your table at, is that points that are in between, okay? Now, here's the nice part. Even though your vertex is ugly, that doesn't mean that like every single point on that parabola is ugly. As you can see, there are some very nice points. Okay? So once again, your vertex is negative 2.5. So the next coordinates you should use are negative 2, negative 9, negative 3, negative 9. Because it's the two that are closest to your vertex, right? Make sense? Okay, even though they're not, 1 unit away like the first one was, there's still that next one that's closest, so that way you can get a nice picture. And then go -1, -7, -4, -7. Plot all 5. And then when you're finished, your graph should look something similar to that. Now, we haven't done one yet that's flipped like this. Okay? And we will next, though. All right, at least we'll look at it a little bit. Now, for maximum and minimum value, okay? Basically, what you want to do, the graph where a doesn't equal 0. The graph opens up if a, or the graph, here, let me read it right. The graph opens up and has a minimum value when a is greater than 0, which means a would be what? If a is going to be greater than 0, a is going to be positive. All right? And it's going to open down and have a maximum value when a is less than 0, which means a is negative. All right? So then whenever opens up like this, that means it's got a low point with the minimum. See that? If it goes the other way, it's got that high point, which is a maximum. Okay? But that point, whether it's a minimum or a maximum, it's still your what that starts with a V? Vertex. So all you got to do is go find your vertex. Okay? That's all you got to do is go figure out your vertex. Alrighty? So, next one. Determine whether the function has a max or min value, and then state that max or min value. Okay? Now, first thing I always look at is my A. My A is -4. Which means my graph is going to open what? Up or down? Down. It's going to open down, down, down. Okay? So think about that. If it's going to open down, and this is my vertex up here, is my vertex going to be a max or a min? Is that going to be the highest point or the lowest point? The highest, so it's going to be a max. So you've already answered half of the question. All right? So you already know that you're going to end up with a max. And I would write that off to the side just so you don't forget. Okay? Once you have that, you do the same exact thing. -b over 2a. So b is 12, so -12 over 2 times, whoops, -4, sorry. Which means you get -12 over what, -8? Which means you have what, -3 or +3 halves, right? Everybody with me now? Make sense? Now, that is what? That's the x or the y? That's the x value, right? Okay? And that really, x tells you left and right? Left and right, not right and left, right? Anybody confused yet? Yeah? It tells you left and right. It doesn't tell you up or down. Up and down would be your what? Y. And the question's asking what is the max or the min of the function. So it happens at 3 halves, but we don't yet know how far up or down it goes. So you need to take that 3 halves and plug it in. Yeah. So take 3 halves and plug it in. So -4 times 3 halves, quantity squared, plus 12 times 3 halves, plus 18. Once again, if at this point you go to your calculator, cool. Alright? So -4, 3 halves times 3 halves is 9/4, plus 12 times 3 halves, plus 18. Someone check my math here in a little bit. -9, let's see, what's that? 3 halves, so 6, so plus 18 plus 18. So what is it, 27? Is that right? So clean it up a little bit. Max is 27. Everybody good?
Yep.
Fantastic. Your homework, page 156. 1 through 10.